Alright, boys and girls, today we are still dealing with polynomials, part 2. Alright, your objective today, divide polynomials using long division. Of course, in order for that to happen, we have to cover some previous materials, such as distributive property, simplifying expressions, exponent properties, factoring, and long division. So, that's how we're going to get that to happen today. Alright, as I have told you before, every class period you're going to see this definition because you must know it. Even if you're not mathematically skilled, you will at least know this definition by the time you leave my class and go into the workforce or college. What is mathematics? The technique to explain, understand, and manage reality specifically by ciphering, countering, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. Again, when you get to the workforce or go to college or what have you, you're going to at least use one word of this definition. If you use at least one word, you satisfy the precise definition of mathematics. Are you going to use all of these words in your profession? No, you will not. Again, as a teacher, the one thing that I do a lot of is counting. I gotta count in terms of attendance every time I put the attendance in, But as a math teacher, I use all of these except for ciphering. Ciphering means to decode, and I don't use any decryption or decode anything in the classroom. But I do make inference. I teach you how to make inference based on numbers. I do create equations to represent a situation, and you will too as well. But as you students, you at most count and you measure the most. You measure in terms of the time you got left before you leave my hard, boring class, or you count in terms of, money, whatever you got going on. Don't forget, mistakes allow thinking to happen. Some of you guys are catching on to this. Some of you guys are still not. And for you guys who are not, again, don't stress out when you don't know the answer. When you get to a point that you don't know, you gotta give me the answer. Just give me something to work with. Because when you take ACT, you may be in situations that you don't recall things well. And so you're going to have to guess because you gotta do that. You can't leave nothing blank. So that's what that means. And besides, this is how you grow. You're not going to get it right the first time, but I guarantee you before you take my test, you're going to get it, provided how much work you put into it. But mistakes allow thinking to happen. Now, if you're not thinking when you make these mistakes, and you keep doing the same thing over and over again, that's not helping you. So mistakes allow us to grow. Mistakes allow us to think. So mistakes allow thinking to happen spells math. Again, math comes from all over the world. I gave you guys a first project to find out, like our number system, which from the video you should know that our number system comes from India, which is over here. This is where our number system comes from, right over here. All right. All right. Let's review our factoring skills. Factoring is a must. Throughout the course of Algebra 2 and your advanced math class, you must know how to factor. You gotta factor. Factoring is an ACT concept. Also, in addition to the ACT deals I told you about, one of the things that will become a grade is the ACT review materials that I will be posting in Google Classroom. I'll talk to you more in details about, because again, an 18 will excuse you from all tests, or 21 or above will excuse you from test and homework. All right, so let's get to it. Let's start with the left-hand side. Let's factor that. So if you don't remember, I got you how to factor. So remember, factoring, this is the standard form of it. You must be able to factor to, again, get the ACT score you want, which is the 18. So let's do it. Left-hand side, you're going to do the following. Figure out what two numbers will you multiply together. Gives you your C term, which is your 54. So your first term is A, the 15, well, coefficient, is B, and 54, the last coefficient, is C. Your first your A term, it has a coefficient of what number? 1. All right, let's get back to it. So we know that 6 times 9 equals 54, and 6 plus 9 gives you 15. Now, if you're struggling with that, it's more of a playing a calculator game with it. So just keep multiplying numbers in your calculator and figure out which two factors give you that 15. That 15 when you add them together, but those same two factors gotta be multiplied together to give you 54. All right, so again, if you're not cool with that, just keep plugging in with your calculator, and I'll give you a lot of factoring reviews so you can know how to factor. All right, so let's do it. So let's put it in factor form now. X plus 6, x plus 9. That is our factor form of that. And that's all you have to do, is just put it in factor form. All right, so let's go ahead and do the right hand side. Now, the right hand side of this is a little bit more difficult and tricky to deal with, because your A term is greater than 1. So looking at this, which one out of those three numbers is my A? It's 2. Good job. A equals 2. All right, so let us get to it. So in this case, anytime you have A greater than 1, you multiply A times C. So 2 times 15 gives us 30. All right, so let's rewrite this. So let me ask you a question. Can you figure out two numbers when you multiply together gives you 30, and those same two numbers gives you 7? We could go to calculator and list factors. 5 times 6 is 30, but 5 plus 6 does not give you 7. 10 times 3 equals 30, but that won't work. The only thing that we have close to that could work is 10 times negative 3, which will give you negative 30. And 10 minus 3 gives you your positive 7x, which will work, but it doesn't give me my 7. I mean, it doesn't give me a positive 30. That's the only issue I have with that. So when you get into a situation like this, you're going to have to factor this with the quadratic formula. On your ACT, it is imperative that you know the quadratic formula. They won't give you a formula sheet, but I got you if you don't remember. One way how I remember this, my teacher used to sing a song, and part of the grade of in her class, you had to sing the song with her. So ready? Here goes. X equals the opposite of B, plus or minus square root B squared minus 4AC, all over 2A. I know I can't see, but that's how we have to do it. So let's get to it. The opposite of B, a B term is 7, right? So the opposite of that is negative 7 plus or minus B squared, again 7 squared, minus 4 times 2 times 15 over 2 times 2. Now, later on throughout the year, we're going to do more practice of these quadratics. But know that when I give you additional practice today or in Google Classroom, I want you to factor stuff that looks like this. All right? Let's move on. All right. You have to take that same exact problem and you have to put it in vertex form. I did say factor, but however, we just realized that that we couldn't factor it like we did the first quadratic that was given to us. So, you know what? Let's try something. So let's change this a little bit. So instead of using 15, let's get rid of it and let's use just 5. Now let's try. See, can this be factorable? So like I told you before, because a is greater than 1, multiply the a times c coefficients. 2 times 5 is 10. Then you rewrite it, x squared plus 7x plus 10. All right, so what two numbers, when you multiply them together, gives you 10, but the same two numbers gives you 7. Forget my handwriting, y'all. 2 times 5 gives you 10. 2 plus 5 gives you 7. So it is factorable. So x plus 2, x plus 5. All right. Now, with that situated, that original a coefficient we have, I would say term, but to be more mathematically correct, any number in front of variables or a number that stands by itself is known as a coefficient. So I would be professional on that one. Anyway, take the a coefficient and divide it by 2 for each number in the parentheses. So 2 divided by 2, that gives you a whole number, right? X plus 1. So 5 divided by 2, do that give you an integer? See, we can no longer say whole number. Every time I say whole number, I gotta use the word integer. Again, whole numbers, you can't really use that term anymore. Because there's more of a childish word. Like, for example, when you say, I gotta go pee-pee, as an adult, it's like, okay, can't say that. I gotta go to the restroom. That's the mature way of saying that. Alright. So because 5 divided by 2 does not give you an integer, you're going to move the 2 to the front, swing it, and leave the 5 alone, 2x plus 5. And this method, what we just did, is called the swing method. The swing method. The reason why you call it the swing method is only because here, that 2 could not divide the 5. Or 5 does not divide into 2 to give you an integer. So you swing it up front. So that's what's called the swing method. Alright. So we factored it. Now let's put this in vertex form. At first I told you guys that I was not going to give you any additional practice on quadratics that look like this, but I will. So let's put it in vertex form. In vertex form, if you forgot, that's okay. That's the reason why I give you the practice, so you recall it. So the vertex form goes something like this: a x minus h squared plus k. I'm using the alternate quadratic. I'm not using 15. I'm using 5. I'm going ahead and make this work. So a is pretty easy. A is just going to be 2. To find h, I'm struggling to talk. To find h, all thing you have to do is the following. And h is called your axis of symmetry. H is called your axis of symmetry. Alright? And to do your axis of symmetry, you got to take the opposite of b and divide it by 2a. So b, in this case, opposite of b, that is, -7. And a is 2. So this becomes, h becomes -7/4. And you can leave it like that. You don't have to simplify it. You're done. You do not have to simplify it at all. Now, remember, as I told you guys before, according to the test administrator at the Strummer, you guys will have access to decimals for your ACT. Another way of doing this quickly without doing all this work that I'm doing is looking at the graph at decimals, getting the vertex point, because your vertex point is your axis of symmetry and your maximum min value. But this graph here, this quadratic here, has a minimum. So let's go ahead and put in decimals right quick and see what we get for the k value. Well, I have to calculate this because I don't have my phone with me to do it in decimals. So let's do it. So 2 times -7/4 square 6.125. (49/8). That's what that is. 7 times (-7/4). And that's going to be 49/4. Now we just have to put it all together and see what we get. And again, if you put this in decimals, and again, if you get the vertex point, which is the tip of the lowest or highest point of the quadratic, you could get your h and k. For some reason, again, I didn't have my phone, so I'm doing it, I'm calculating it. But again, you will have decimals on your ACT according to the test administrator, so you can move on. So I get something like (-9/8) for k. And again, I just took this (-7/4), I just plug it in for every x value. That's all I did. And that's gave me this guy here. All right. So now let's put it. So the vertex point I get is (-7/4). Boy, it's positive. When you go in the decimals, you're going to get a positive (7/4), not negative. (-9h). Now, we got the vertex point. Now we can put in the vertex form. And now we could get ready and move on. So we got 2x plus 7/4. Although it was originally negative, but when you put a negative here, that negative sign makes it positive. Negative times negative is a positive. Minus 9-8. All right. And again, the 7/4 is the h value, or our axis of symmetry. Now, for this part here, I don't want you guys to worry about getting the vertex point at this moment, because I think I got that h, the sign's incorrect. However, in this format, that is that. So again, I don't have my calculator on me, so your h may be negative still. The vertex point may have a negative h, but according to this, it does. But when you put in the function, it's positive 7/4. All right, I talked a great deal about this, so we're gonna move on past it. All right. You're gonna factor this one out. You're gonna try it on your own. All right. So let's go back to last class period and review from what we did here. Now, going back to our exponent rules, we had to factor. What is the one thing that they both have, all of them have in common? They all have, and what I mean what they have in common, I mean in terms of the variable z, what do they all at least have? All at least have. They all have a z to the power of 2, because for the z cubed to happen, you have to have a z squared times the z, which gives you that z cubed. Alright? If you don't believe me, you could simply just subtract. Because remember, when you're dividing, you subtract the exponents, going back to the exponent law. So z3 minus z2, that's just z by itself. Well, 4z, when you simplify it, 4z. So z squared minus z squared, that's just z to the power of 0, or just 1. So that's going to be plus 6. Just like that. And again, using the exponent laws, when you are dividing, you are subtracting the exponents from these same variables. Now all these have the same variables, so you can subtract them like that. What are these two functions? Starting from the left, what function is that? Quadratic. How do we represent that without writing the word down? X to the power of 2. What about the graph in the blue? Cubic. How do we represent it without writing its name? X to the power of 3. How do we know on the left hand side that it's an even function? Yeah, just look at your exponent. The exponent is 2, so it's an even function. And by looking at the graph, it's symmetric around the y-axis, meaning that if I was to split it in half, it would be a perfect symmetric around the y. Also, I could rotate it around the y and I still have that same piece. What about the cubic function? It's odd. How do you know that it's odd? Power of 3. And it's symmetric around the x, or you could just say the origin. So that means that if I was to spin this around the x-axis, I have equal pieces there. All right, next work. Moving on. Which pair of functions are called polynomial functions? Linear, which we represent just like x, because that's a linear function. Quadratic is 1. And cube is 1. All right. So why can't the square root be a polynomial function? Well, it has a square root. And also, you could rewrite the exponent as a half power, but it has to be an integer exponent, so you can't have that. Why can't rational functions be polynomial? Well, you can't, divide stuff. The exponent, because the exponent, when you're doing a rational function, you could rewrite that as a negative exponent, which you can't have a negative exponent. Exponential can be 1, logarithmic can be 1 either. under the same principle of this. Alright? Alright, let's review what a polynomial is. A polynomial is a function of the form ax, a subscript n, x to the power n. So long story short, the degree of a polynomial is the highest power of x in an expression. Constant non-zero polynomials, linear polynomials, quadratic polynomials, cubic, and quartic polynomials are polynomials. But they have a degree, must have a degree of 0, 1, 2, 3, 4, respectively. The function f of x is a polynomial, but is undefined. So I got a question for you. Why is this not a polynomial function? On the next thing, I need for you to handle that. Find that on your own. I'll check it out, see how you do. Alright. I'm waiting for you to tell me the answer of that one. So you do this one on your own. Alright, long division. I haven't did long division in a while. For today's main lesson, you're going to have to do the long division without the calculator. I know we're so used to it, but you know, for what we have to do today, you must know the long division method of this. So let's set this up. And we're going to do the silly little acronym. Okay, let's do the D part, which is divide, but also means does. 6 divided by 3. So how many times does 3 go into 6? 2 times, right? Multiply. Let's do that step. Or, as we call it, McDonald's. And I do apologize about my handwriting, but it's just me using the touchscreen versus my stylus. So 3 times 2 is 6. Subtract. Let's look at cell. So 6 minus 6, 0. Check. Cheese. We know 3 times 2 is 6. 6 minus 6 is 0. Bring down burgers. So remember the acronym, does McDonald's sell cheeseburgers? It's pretty much this process. Alright, so let's do it again. So divide 3. How many times 3 go into 7? 2 times. 2 times 3 is 6. 7 minus 6 is 1. Alright. Bring down the 9. Alright. Let's do this again. So can 3 go into 1? No. 3 doesn't go into 1. What about 19? Well, 6 times. 3 times 6 is 18. 19 minus 18. Subtract it, bring it down to 1. So the the final answer to this division problem is 226 with a remainder of 1. So, if you're struggling through this long division, doing it by hand or whatnot, I have long division practice you can do. Again, for the lesson or the objective, we have to learn how to do long division, and you have to know how to do all of that in addition to working with the exponents. All right, so now we get to divide polynomials. We did long division. Now we divide polynomials by doing long division, and this is just part 2. Last time we canceled stuff out, but now we gotta do it the long division. All right, so we got something like this going on. Geez, how we do it? It's the same process except for the x plus 1 is what we're going to do everything with. So let's get a shot with it. So I wrote it out like this. The first thing you want to do is divide 5x squared by x. So go back to your law of exponents while you're doing this division at the same time. 5x squared over x. Remember, using the exponents, your law of exponents, when you divide, you got to subtract the exponents. So that's going to become 5x. All right, so that's step 1 we just did. Step 2, now we have to multiply. All right, multiply x plus 1 by 5x. All right, and remember, when you are multiplying exponents with the same base, guess what? You gotta add them. So 5x times x is 5x squared. All right, so that's just a thing to remember, because 1 plus 1 is 2. All right, so let's get back to it. So when I multiply x plus 1 by 5x, and make sure I don't forget my distributive property, I get 5x squared plus 5x. All right, next thing, just like long division with integers, you gotta subtract. So when we subtract, 5x minus 5x squared is 0. 3x minus, because I have to subtract everything here, and you see this minus sign right here? There's outside the parentheses, all I did was distribute here to make that negative 5x to cancel out. Then I distribute that same negative sign over here to make that a negative 5x, which gives me a negative 2x. All right, and remember, when you are adding, not multiplying with exponents, you can't do nothing with them. Again, this 3x minus 5x, you don't do nothing to the exponents because these both have an exponent of 1. You leave those alone. Again, multiplication, division, when you make that happen. All right, next up, break it down. And what I mean by bring down the 2. And guess what? You're going to repeat the process until either you have a remainder, until you're not. But this particular part of this lesson, you will not have a remainder. Subtract on the 2. Let's keep going. And repeat the same process again. Negative 2x divided by x. That's going to give me negative 2. Multiply x plus 1 by x by negative 2. Then just subtract. When I subtract all of that, when I subtract here, that's become a positive 2x. So that cancels that out. And then when I distribute again, that becomes a positive 2. That cancels out. That gives me 0. And that's how you do that kind of problem. All right. I'm going to do one more with you. And then I'll let you get some practice on your own to do. Okay, so let's go ahead and get started with this one. So, divide. If you cannot see this because it's pretty blurry, because this comes from your Eureka lesson, this is what I'm writing. So I'm telling you x plus 3 as the divisor. Well, x plus 3, of course, is outside. And then inside, of course, is x cubed plus 5x squared plus 7x plus 3. All right, let's get this show on the road. All right, first step, divide x cubed by x. Gives you x squared. Go back to your law of exponents, all right? Multiply x squared into x plus 3. That gives me x cubed plus 3x squared. All right? Subtract. Make everything negative. Everything's got to be negative. So instead of it being plus 3x, it becomes minus 3x. So x cubed minus x cubed cancels out. 5x squared minus 3x squared. That gives me 2x squared plus 7x plus 3. All right. So now let's do it again. There's a 2, but for some reason I can't curve it good enough. So 2x squared divided by x is just 2x. All right. So 2x times x is 2x squared. And then you multiply the 2x times 3, which gives me a 6x. Now, again, you gotta subtract. So negative here, negative here. When I subtract 2x squared minus 2x squared, that goes bye-bye. 7x minus 6x is just x plus 3. All right. Now, let's get to the finale of this. Doing it one more time. Take x divided by x. That's just 1 because I'm using the law of exponents. 1 times x is x. 1 times 3 is 3. Now I gotta subtract, make everything opposite. So x becomes negative, positive 3 becomes negative 3. And so when I subtract everything, I get 0. So my quotient is x squared plus 2x plus 1. And that is how you solve that problem. Ladies and gentlemen. All right. I want you to try this one on your own. I know it's big. If you practice those steps, it's going to be good. Now, if you're still struggling with this afterwards, I will provide you with more practice. Again, this has essentiality to your ACT.